Hello and welcome to the Nerdy Things channel. Today we will discuss internet basics such as IP address and port. We'll go through the most common used protocols like TCP and UDP. Also, we will review what is HTTP, what is WebSockets, and what is Datagram on simple examples. Let's begin with IP address and port. Each device in the worldwide network has its own address. It is called an IP address. We have two standards, is IPv4 and IPv6. But in this video we will speak only about v4 because it's simpler. IPv4 addresses have a strict formats like 12.34.56. and 78. It's 4 number, each could be from 0 to 255 and they are separated by a dot. We can imagine World Wide Web as a city and look on this map. Each building on this map has its own address. For example, 399 on 9th Street and 309 on 9th Street. And each particular building on this map has its own address. And same story happens if we think about this map as a computer map. Each computer in the worldwide network has its own IP address and can be illustrated on this map. We can see one IP address and another and more and more and more. So if you want to visit someone, you can use this address. In real life, tall buildings have address and apartments. And same happens with computers. Computers have ports. So each server application lives in apartment, and it means that a server application listens to a port, and if some clients want to communicate with this application, they use IP address and they use port of this application. To be able to communicate with each other, computers use communication protocols, and we will review them next. Let's start with TCP protocol. Imagine that we have a pizzeria and a client on a distant sides of the city. And a client wants to order a pizza. He makes a call. Hello, is it pizzeria? Hello, yes it is. I want to order a 4-cheese pizza. It's not a problem. Where should we deliver? 29th Street, apartment number 16. It will be ready in 15 minutes. We are on the way. Thank you. Would you be surprised if I say that you just witnessed a single TCP IP connection and data exchange? Yes, a person called to a pizzeria, they made a handshake and greetings, and they exchanged needful information between each other. It's exactly the same way as a TCP connection works, and HTTP in particular. One device sends requests to another one, and both receive some information in a real-time exchange. After a private one-to-one conversation, the connection is closed and everyone knows that the recipient is aware of what was requested and responded to. The next TCP connection session will deliver the pizza. Unlike TCP, UDP is more like shouting in a crowd. You can shout out to multiple people at the same time, but you never know if the recipient heard your message. And it's really fast to shout something rather than deal with greeting and acknowledgements, especially if you don't know where your recipient is located. Let's apply UDP to our pizza situation. Cartman tries to order a pizza without using a phone. It's faster for him just to cry for it. Eventually pizzeria will respond to him and it will send a pizza at some point of time, but Cartman doesn't know the current situation with the order. So let's summarize what we learned about TCP and UDP. In TCP, computers are connected during communication. In UDP, they just send data to the network. In TCP, we know when message was delivered, while in UDP we don't know if it was delivered at all. TCP is reliable. If our messages are important and we don't want to lose them, it's better to choose TCP. On the other hand, UDP is fast. If we want to send a lot of messages and it doesn't matter for us that some of them will be lost, we can use it. Last but not least is that TCP is one-to-one communication, while UDP could be either one-to-one or broadcast. It means that on TCP you can establish connection between two computers only, while on UDP you can send a message to a set of computers, or send a message without any recipient at all. It's time to move on to HTTP protocol. HTTP is a communication protocol between two computers. It is built on top of a TCP connection. When you type in your browser http://google.com, the browser will request the IP address of this site and it will establish a TCP connection to the server. By default, HTTP uses port 80. After the connection, they have to use the same language to be able to understand each other. This is exactly what HTTP is, a language or procedure of communication. The analog in real life is communication with the government. You can tell them, give me the form, but it usually won't work. You have to use some greetings and explain what you need. The same happens with HTTP. Let's make a real communication using a telnet command. If you don't have telnet, just Google it. It's available for Mac, Linux and Windows. Okay, let's open command line and type telnet and google.com and port 80. Now we will see that we are connected. Let's type the command get and http 1.0. It doesn't look exciting, but it's a real response from a Google server, and this is how a web page looks like. And the last line is a connection closed by foreign host. It means that server returned everything and closed the connection. Let's scroll up a bit and see what we have in response. This is the response from the server, and we can see that it responded OK, and also it added some headers. Now let's review the structure of HTTP requests. The first line, or the start line, is 3 sections separated by spaces. On this screen we see post, we did get, and post means that it's a type of request. And it could be post, get, put, delete, or whatsoever. The next part is slash, and it means that it's URL of request. In our case, we requested the main page, but it could be also search, for example, or any other. And the last part is HTTP 1.0 or 1.1. It's a version of HTTP. After the start line, we have headers. It's a key value pairs. Headers contains useful information about the client and the request. There could be the language or browser type or content type or like any other information. If we try to find analog in real life, it would be a document or a form where we have like first name and name John, last name and name Doe, and birthday and a date. The last part of HTTP request and response is a body. It's separated from headers by an empty line. The body contains anything like HTML, XML, JSON, plain text, bytes, and that's how we pass data to the server, big data, and that's how we received a lot of data like HTML pages or images. To summarize, HTTP protocol is a short communication between a server and a client, where two computers do next. A client connects to the server via TCP connection. A client sends a type of request and headers, and sometimes body. A server returns the data in a similar format and with the first line, with headers and with body. A server closes the connection and that's it. The next topic is WebSockets. WebSockets use the same TCP protocol. The communication happens from client to server and backwards. But unlike HTTP, WebSockets don't break a connection after the first messages. While HTTP is like a small talk in the elevator, WebSockets are like a long conversation with a friend in a pub, where we have plenty of time to chat and no need to go anywhere. except for small breaks due to the network errors. We will only break a pub connection when we complete everything. WebSockets are very handy when we need to know the latest changes instantly. For example, if we have a very intense football game, we want to know each goal right after it happened. And when the football game is over, we can close a connection. To see the WebSockets in action, we will use WebSocket application. Please install it from the link in the description of the video. Now let's open a command line and type WebSocket and server name, it's vServer and /mirror. It's an HO server, it will return the same as we sent to him. Like if we sent 1, we received 1, if we sent 2, we received 2, 3 and 3, 4 and 4, R and R, and now let's type a long message, it will be returned from the server. And to close connection we can press Ctrl+C. A real server will return meaningful data, but for our purposes for tests we used HO as example. And that's it for WebSockets. And finally we came to UDP Datagram. UDP Datagram messages are relatively small. They have headers and bodies, but these headers are 8 bytes in length and the bodies could be no more than 65,000 bytes. It's like 0.06 megabyte. In HTTP, for comparison, headers could be up to 4,000 bytes and sometimes more, and a body there could be more than a gigabyte. UDP messages are not designed to transfer a huge amount of data. Let's review how UDP messages work in a local network. Imagine that we have 4 computers and a router, and one computer decides to send a UDP message to another. There is no connection, it's just tiny message. If a desktop needs to send a message to all computers, it will be the same tiny UDP message, but it will be delivered to everyone in the network. The main usage of UDP Datagram is quick asks and broadcasts. To understand better how broadcast messages are useful, imagine that you are a teacher and you have a full class of kids. You know that one of kids has a birthday today. In TCP, you will be required to ask each child about their birthday personally, but using UDP, you can say who has a birthday today and wait for a response from one of the children. It's the same story about computers. One computer could ask who is the server, and the server could respond I am and IP address is, and send his real IP address. That's it. If you find this video useful, let me know in comments. See you, bye.